Hey, once again, welcome back, folks. This time around, we are going to, using the information that we discussed about on the first series, just try and see if we can draw solutions to these problems below. Here we are interested in going through the fetch execute cycle step by step. So the first step that we would find here in the fetch execute cycle is the program counter value is copied to memory address register. So program counter value copied to memory address register. So that is the first step that we have. Then address is sent to the memory. Now we have address sent to the memory is our second step. Then third step, we are going to have instruction being copied to memory data register. So that's instruction copied to memory data register. Then from there, after instruction has been copied, we have instruction transferred to current instruction register. So instruction transferred to current instruction register. Then from there, we have instruction being decoded. Then the next step is decoding of instruction. So here we can say instruction decoded. Then the next step that we have there, we have instruction being executed. So instruction execution. So instruction will be executed. Then the final step, we have the program counter being incremented. So PC incremented. Then the process starts all over again. So interrupts are checked after each cycle. So normally we'll be interested in interrupt checks. Interrupts are checked within each cycle. Those interrupts are given high priority, so they need to be checked and given their uh, uh, first priority because they might force programs to malfunction or misbehave. So it is very important to check whether within each cycle do we have any interrupts. If not, then the program counter is incremented. Then next, we are interested in interrupts and how they are handled. So interrupts, they allow our CPU to respond quickly to important events. So they allow PC to quickly respond to higher priority or important events, to respond to important events like the ones that I was commenting earlier. We have errors which can cause the machine to terminate or stop its operation. So we have input-output requests. So you can say IO requests. These, they are interrupts with high priority. Sometimes you open the drive of a CPU, I mean, that has to be given its time. So we have hardware faults. Sometimes beep sounds, they tell you that maybe a keyboard is malfunctioned, or so we need to quickly check what will be going on. Software errors. Software errors. Office fails to boot correctly. I mean, there are interrupts that will come to the screen to say your document did not load properly. What can we do? So we also have timer signals. They are part of interrupts. Then how are interrupts handled? because when interrupts occur, I mean, they have to be given their priority. So in handling interrupts, we don't want to miss the position where we were during execution. So current state is going to be saved. So current state saved, so that should we exit the interrupt, then we need to resume. So when current state has been saved, interrupt is saved or handled. So interrupt, handled, and once it has been contained or handled, then program will then continue from where it left. So program resumes its execution, or it continues with its operation from the same point that it halted. So that is how interrupts are handled. Then ports and peripheral connection. We've got different ports that we would find within computer systems, and our interest is to understand their purposes. So I'm going to enlist a port type and its use. So we're going to talk of port and its use, because various ports have got different functions. So we have USB. USB, like we said earlier, is a port, not a device. So these general devices are handled, such as keyboard, mouse, printers, you name them. So that's a port. Next, we might talk of HDMI, high definition media interface. This one, its purpose is especially on video and audio output. So it's visual, video, and audio output. So we need uh, what HDMI. So those are ports. And then sometimes we might be interested in communication. If we want to communicate, we need a port responsible for sending and receiving data. So for communication, the port is Ethernet. So Ethernet is designed for networking and communication. So that's network connection. Finally, we have audio jack. Obviously, from the name itself, it's responsible for sound output. So this one is sound input or output. Sound input or output. That's the audio jack. So let's proceed with these 10 questions, where first we are required to define the von Neumann architecture. We spoke about it earlier that it has got a number of steps that involve processing of data. But when we talk of the von Neumann, we are interested in concurrent usage of both data and programs. So von Neumann architecture, this is architecture where both programming instructions are stored in the same main memory. So both program and data are stored in the same main memory. For our case, normally it will be RAM. So same main memory. And when it comes to accessing, they are accessed using the same set of buses. And access using the same set of buses, which normally brings us to the von Neumann bottleneck, where we are saying uh, you know, the parties might be overwhelmed by both program and data to be executed. Now, the next problem we are interested in disadvantage of the von Neumann model. One disadvantage, which is main, I think, is the bottleneck. So the bottleneck leads to uh, slowing of the entire process. So because we're using the same bus, then it leads to limited data transfer. Well, there are two things which are occupying the system, which is both data and program. So that's one of the disadvantages of the von Neumann module or architecture. Now, the next question we are interested in describing the role of program counter. So program counter, which we said earlier, stores the memory address of the next instruction to be fetched. So this it stores the address of the next instruction to be fetched. Stores address of the next instruction to be fetched, as well as the execution process. So, and it is incremented after each instruction fetch. So this is incremented after each instruction fetch. Then next we have the memory address register. Now our interest is what is stored. This stores address of memory location that CPU wants to access. Address of memory location that the CPU wants to access. That's the purpose of memory address register. Then next is memory data register. So MDR or memory data register, its purpose is to temporarily hold data or instruction. So this one temporarily holds data or instruction uh, that are being transferred to or from main memory. Being transferred to or from main memory. That's the purpose of memory data register. Right, now we're interested in the difference between arithmetic logic unit and control unit. So here we are going to be interested in actions being performed in the ALU or arithmetic logic unit. ALU performs logical and arithmetic operations, things like yes and or uh, addition, subtraction. I think those are the things that are performed in the arithmetic logic unit. But with control unit, these controls and coordinates, here we have got controls and coordinates. That's the control unit. It controls and coordinates the execution of instruction. The execution of instructions um, which are uh, done by sending signals. Then next, we're interested in listing three main stages of the fetch, execute cycle. Obviously, it's fetch, decode, and execute. Fetch, decode, and then execute. Then next, we're interested in an explanation of what an interrupt is. So we were saying an interrupt, this is a hold to the normal performance of program execution due to events that, if not taken care of, they might lead to CPU collapse. So an interrupt is just a signal that causes CPU to temporarily, so you're saying a signal that causes CPU to temporarily stop its normal executions or its normal processes. Uh, then current program to respond to priority event. So we are interested in two examples of interrupt sources. This can be hardware or software. So let's talk of keyboard or mouse click, keyboard press or mouse click. Those are some of hardware interrupts. Mouse click. It's like there's an instruction being sent which needs the CPU to attend to immediately. So we also have hardware failures. So hardware fault, like paper jam, that's an interrupt when you are using a printer. Uh, there's a signal which is sent to say uh, the printer is run out of paper, so it cannot continue with the printing process. Identify a suitable port for connecting a printer and justify your answer. Obviously, it's a USB. A USB port, that's universal serial board. This is a port that's used to send data in serial format or one bit at a time in a single line. So here we are saying it's USB because we are interested in operational efficiency. Well, it supports uh, fast data transfer, fast data transfer, and supports a variety of modes or models of the same devices, including printers of devices, including printers themselves. If they come in different modes, they can all be connected via the USB line or USB port. I hope you guys you found this session informing. I hope we'll meet in the next topic as we cover computing science for AS or A level. Thank you.